So taking a look at some applications of quadratic functions, most of these that you see in this chapter are optimization problems. And that's really just fancy for basically asking you to find the maximum or minimum. And if they don't particularly say maximum or minimum, it's kind of another idea to ask you to find the vertex. So sometimes they might not say it straightforward, but we have to understand what it's looking for. So the first, some of my favorite ones to work with would be one of the rocket problems. I like these because they kind of already give you the equation that you're going to be using. So all you have to do is kind of fill in the blanks, knowing what the problem is giving you. So they're talking about a rocket being fired upward from a height of 50 feet above the ground level with the initial velocity of 1,200 feet per second. They want to figure out when the rocket will reach the maximum height and what is the maximum height. So lucky for us, they give us a formula. We don't have to memorize it. We just want to fill in who is the initial height and who is the initial velocity with actual numbers. So you'll notice that I highlighted this. So let's kind of modify our h of t function. Negative 16t squared. But instead of v sub 0, that's the initial velocity, we should write a 1200. And instead of h sub 0, we should write the initial height, which is 50 feet above ground level. So that's going to be plus 50. Now it's not completely in terms of x, but we do have a quadratic function right here. I mean, and most of the time in real life, they use variables that make sense to the context of the problem. So t standing for time, very useful. But remember, quadratic functions have the form ax squared plus bx plus c. So if you can kind of look at what we're dealing with, we have t's instead. So h versus t. A would be negative 16. B would be 1200. And c would be 50 if we were trying to determine this. Now we also know, without having to reach for our TI, we do know that the graph of this quadratic function is a parabola. And the fact that we have a negative squared term means that our parabola will be opening downwards. So what we're interested in and what we'll probably be looking at is what is the maximum height and when will it reach it? And so basically that's code word for finding the vertex. So now you have your choice. There's no method that's specified. You could do completing the square to get it into vertex form to find the vertex. You could use the vertex formula if you remember it, or you can use your TI. I'm going to show you the vertex formula and the TI for sake of time. If you remember formulas, they're great to pull out. So I'll do the formula first, and then we can verify with the TI and then kind of talk about the differences. So if I want to find the vertex, I do remember the vertex. Remember, we used to talk about this in terms of x, y. But the way our function is set up is that the dependent variable is not x, it is t. And the independent variable is t. The dependent variable is h. Always have to remember. Now, if this is the case, we'd be saying what is the t value of the vertex? And that can be taken by negative b over 2a. And so if we want to plug this into our formula, we have a negative sign. B is 1200. A is negative 16. So we're just being really careful with the signs. We do have negative over negative, so we do know it's positive. So we do have 1200 over 2 times 16, which I believe is 32. Feel free to compute this in your calculator. So I do have 1200 over 32. I do want to talk about time. So let's do our calculator, 1200 divided by 32, and we do get 37.5. And so if we're trying to understand what does this mean in the context, T stands for time. So time is measured in our case, looks like they refer to seconds in the initial velocity. So we'll go with that measurement. So we should have 37.5 seconds. Now we're also interested in figuring out what is the height. And so let's look at that again. We would actually take our t value of the vertex and plug it into our function. So our height, our h of t, that's h of 37.5. So we would plug that in, negative 16 times 37.5 squared, plus 1200 times 37.5, and plus 50. And it looks a little tedious, but we've got our calculator to help us. So 37.5 squared, just so that you know, I'm using my calculator for this. I should get 1406.25. 1200 times 37.5. Using a calculator, I'm getting 45,000 plus 50. So a little bit more math. Negative 16 times 1406.25. Negative 1422.25 plus 45,000 plus 50. So we go ahead and use our calculator. Just being careful in the zeros because sometimes that gives us issues. And let me double check. I think I accidentally pressed a minus sign. Let's try this one more time. Negative 16 times. See all the things that could happen while we're talking and discussing. I think I did subtraction. So you probably caught that, so good on you. It's negative 16 times 1406.25. There we go. I thought that looked a little weird. Negative 22,500 plus 45,000 plus 50. There we go. So now we can use this. And we ended up getting positive 22,550. And so we kind of want to make sure we are dealing with context. So we really understand the units of the problem. That's going to be very important. Since we're dealing with h, and h stands for height, we kind of go back and look at what the height was measured with in our problem. And I do see references to feet. So I do believe I'm going to have the feet from here. You either spell it out or use the abbreviation, totally up to you. So we did find the vertex, but you know, the context of the problem doesn't want you to label it, you know, 37.5 and 22,550. That's kind of not useful in real life when we're trying to speak to actual people. So we want to actually answer the questions of the word problem. So when will the rocket reach its maximum height? Right away, I talked about the when part. When is usually talking about time. So I might rephrase this like it takes 37.5 seconds to reach maximum height, or reach the maximum height. And then they ask, what is the maximum height? And so I would probably rephrase the h instead of just saying, hey, h equals 22,550. I might just say, hey, the maximum height is 22,550 feet. And that's what makes you the big bucks. You always rephrase your math findings into real life people English, and people like you a lot better. So that takes care of the problem. But before we sign off on this one, I do want to show you a little bit about using the TI for some problems that could be a little more with larger numbers. We will still get our same answers. So if you're comfortable with this stuff by hand, no problem. But I do want to show you what happens when we do use the TI. So one last thing, we're going to pull out our TI and plug in our function to the function editor. So we do have our old graph from one of the past examples. Everything's only in terms of x's and y's, so we're going to have to deal with it. So what I'd be looking at, instead of negative 16t squared, I would say negative 16x squared. Then it's plus 1200x instead of t plus 50. So a lot of times when we start dealing with these real life context problems, when you graph it, you will notice that your standard viewing window doesn't always give you what you need. And we might have more experience with this along the lines, maybe a little bit later in this chapter, but I'm going to show you a shortcut right now just in case. You could play with the window, and if you understand a little bit more, you can kind of test out, I gotta widen out the x min, x max, or y min, y max. I prefer to try it this way. It doesn't always work, but I'll go with it. I'm gonna look at the window, and actually I'm gonna press zoom, and I'm going to scroll down to, I'll show you, press the arrow key downwards. We should have a function called zoom fit. And what that does, if we use it, it gives you a general idea of the window to use for your function. However, it doesn't really show you your full function, but it does narrow things down a bit. So I always like that at least. So if we remember, let me go back a little bit just so that you can all see. We actually are looking for a parabola that faces, which way? Downwards, yes. So when we kind of look at our graph that we have, it appears that we probably won't need the left-hand side. Usually there's no negative time values in this particular class we're taking. So it looks like I'd want to, raise out my, widen out my x max. That's the right-hand side of your graph. And it is possible the y max might be a little more interesting too. So this is kind of giving us a nice starting point. So what I'll do with my window, sometimes if I can kind of see the curve happening, I might just say, hey, what if I double it? And x max is 10, so maybe if I made it 20. Sometimes I'm just, really excited. I might just say 50. You could always make it smaller, but sometimes if you make it too small and you have to keep incrementing up, and like it's annoying. So let's go big, see what happens. So I'm gonna do this one at a time so I know if I have to fix anything. You can modify the settings all at once, but I don't recommend it until you're really comfortable. So now you can kind of see like, okay, well, it's looking like we're gonna have to widen out the y max. And right now, let's see what the y max is in the window. Right now it's really huge. And I know we've already done this problem by hand, but sometimes you might want to say like, let's double it. Let's see what happens. 10,000, we'll just double it to 20,000. Like I said, you can always bring it back down, but sometimes going further out helps you see it. So now I'm starting to see where the maximum might be. I see that somewhere over here. That kind of gives me a little clue to maybe widen out, make my y max a little taller. So I could do that. 20,000. Maybe we make it 30,000. If we had to double it, go by 10,000. Sometimes that helps. And then you start to see, aha, it's right there. There is the vertex over here. I'm kind of scrolling around there. Problem being, you don't really have to worry about it, but if you really wanted to see the full parabola, you do kind of can tell by the right side of the graph that it's going to move down. You may want to adjust it. Like I really like things that are symmetric, and I guess that's just my problem, but sometimes I may just say like, what if I made the x max 100? It does help me see a nice, pretty parabola. Makes me a little happier inside, but Up to you. As long as you understand where the vertex is, you can calculate it directly using the TI as long as it's viewable in your screen. So now what we can do is press second trace. And this time, it looks like we're looking for a maximum. So that's a number 4. And so we would use the arrow keys to go a little to the left. And sometimes when it looks like it's flattened out, maybe go a little further than you think it would be. So left bound. Keep pressing, pressing, pressing. Go a little bit further, maybe exaggerate a little bit when it's flattened out. So we do know our vertex is in between these two left bound and right bound X values. Press enter. And then right away, we're like, looks familiar. So I do remember when we calculated from the formula, we got 22,550. But I do believe when we calculated from the formula, we actually got 37.5. And this is kind of interesting, depending on how you choose your left bounds and right bounds. Remember the lack of technology with the TI. You're only smarter than the TI. Usually when you see more than 3 9s in a row or more than 3 zeros in a row, you can invoke rounding for yourself. So this is not really 37.499995. It's really just 37.5. So we would still answer the same question. And you can kind of notice, we can go back. And you can kind of see like, oh yeah, we did figure it out. It's here, 37.5, 22,550. If this were maybe a test that required work, you would then quickly just sketch. If you solved it using the TI, you do your best and make a quick sketch. And it doesn't have to be super accurate, but just enough to know that, okay, the vertex is in the first quadrant somewhere. And so that kind of helps us with that. So I'll let you kind of play around. Sometimes, you know, a lot of us are patient enough and it's useful to kind of play with the TI. It's not too horrible, but I know when you're first starting out, it could be intimidating. So maybe you might be more inclined to use the formula, but I wanted to provide you with both options. So I hope this helps. I'll see you for the next example.